Hello Algebra 2 students, this is a video for the second half of section 1.7. Got some word problems for us to try. A party planner charges customers based on hours, guests, and tables. A record of the invoices for the last 3 customers is shown. What is the per unit charge for each element? So when you're looking at a word problem, we want to decide how many different variables there are, and they very nicely said it right in the first sentence. It's based on hours, guests, and tables, and I can see I have hours, guests, and tables totaling a charge right there. So you may be able to see what the 3 equations are going to be. 3x plus 20y plus 4z is going to equal 370. Okay? So we have that equation. 4x plus 35y plus 2z equals 560. And same thing with this. Now this might have been straightforward. We're going to do another problem by the end of the video, and maybe it won't be as straightforward, but we know this is the matrix. This is the system of equations, and this is the augmented matrix, and then we're just going to compute by finding the RREF, and it came out to, if you don't mind zooming in here, or I need my glasses, 1. So there's x equals 50. Oh, they wrote h, g, and t, but I know x represented hours, so I have 50 hours. No, it's not 50 hours. I'll explain it later. X equals 50, y equals 10, and z equals 5. Now these, we already had the number of hours, guests, and tables, and the total cost was this. So these are the charges per hour, per guest, and per table. It's $50 an hour, it's $10 per guest, and it's $5 per table. Let's see if they have that down here. Here it is. Hourly charge is $50. Charge per guest is 10. Charge per table is 5. So that may take a little extra thing. When it's interpreting, when it's a word problem, we often have to interpret. We have to go back and read and figure out what was represented by X, Y, and Z. All right, let's try another one where I'm going to use my graphing calculator. This question is actually repeated right here, so if you don't mind. A student has $128 in a savings account. If she were to withdraw the money and was given one, $5, and $20 bills, how many bills of each denomination would she have? Assume she has a total 28 bills, and she has 3 times as many $1 bills as she does $5 bills. Oh my gosh. Well, first, is this a problem that has 1, 2, or 3 variables? And she was given, I notice here, 1, 5, and $20 bills. So that's going to be the number of, I'm thinking it's a 3 by 3 matrix, or 3 by 4 again. The number of $1 bills will be X, the number of $5 bills will be Y, and the number of $20 bills will be Z. And we know there's 28 bills, so here's my first equation. X plus Y plus Z equals 28. All right, what else do they tell me? Assume she has a total of 28 bills. She has 3 times as many $1 bills as she does $5 bills. Oh boy. 3 times, so the $1 bills is X. And the $5 bills is Y. She has 3 times as many 1s as 5s. So she has more 1s. The number of 1s equals 3 times the number of 5s. Sometimes students write 3x equals 1y, but it's really, she's got way more $1 bills. This is the number of $1 bills, and it's going to be 3 times the number of $5 bills. We have 3 unknowns, so I need another equation. Let's see if there's anything that I forgot. A student has I haven't used this yet, $128. So how could I use that? Like this. If this is the number of $1 bills, plus if I take the number of $5 bills and multiply that by 5, and then I take the number of $20 bills and multiply that by 20, I will get $128. I'm going to speed this up right now. I'm not going to type it in because we've already had the video go for a while, but you should be able to take this equation, or system of equations, come up with the augmented matrix, type in the augmented matrix, and then find the RREF for it, and that should tell you the number of $1 bills, the number of $2 bills, the number of $3 bills. Go ahead and figure that out. Come back and I'll show you the answer. The answer is, she'd have 18 ones, 6 fives, and 4 20s. Okay, your teacher will assign you some problems based on this video. That's all I have for you. Have a great day.